My name is Anodi and Mgeta. I'm taking Bachelor of Science with Education in Mathematics and Informatics. Here I have my fellow teachers, Anodi and Jumanne. We are going to demonstrate our project on finite and Cauchy integral formula. Okay, now let us start with finite integral.
Finite integral are integral defined in a certain limit or interval. Example, integral from point A to point B. It is denoted by integral from A to B f of x dx, where A is the lower limit and B is the upper limit, and always A is less than or equal to B.
Now let us consider the real life application of finite integral formula. First is to determine the volume of a liquid in a vessel. Example, in a jerrycan. So the volume of a liquid in a jerrycan is determined by using the formula which is given by volume of a water in a jerrycan is equal to integral from h1 to h2 pi r square dh. The amount of water in a jerrycan is determined by height.
Consider now we have a jerrycan here. This is the radius and this is the height. Okay, now let us shift to another part of our project task, which is Cauchy integral formula. Cauchy integral formula is a fundamental result in a complex analysis which gives the value of an analytic function at any point inside a closed contour in terms of a complex integral taken along that contour. Let f of z be an analytic on and inside a simple closed contour C, and let A be a point inside C. Then Cauchy integral formula is given by f of A is equal to 1 over 2 pi I integral at contour C f of z over z minus A dz. The formula shows that the value of an analytic function inside a region is completely determined by its value on the boundary. The term 1 over z minus I acts as a weight factor that singles out the value of z is equal to A. The integral f at contour C f of x represents summation of the function value of the closed contour C. The constant 1 over 2 pi I normalizes the integral to give the exact value f of A. Now, let us consider the mathematical connection of the Cauchy integral formula at home. When you are cooking at home, boiling soup, eggs, baking breads, the Cauchy integral formula explains a powerful idea. The temperature at any point inside food depends only on the temperature along its boundary. This is exactly how an analytic function behaves. For any analytic function, the Cauchy integral formula says temperature at point A is equal to 1 over 2 pi I integral to contour C Tz over z minus A dz, meaning that T represents temperature. Therefore, interior temperature is equal to boundary temperature influenced. Consider we have a cooking pot here. We have a lid and inside there is a soup. The temperature of the soup is equal to the temperature of the boundary of the cooking pot. This gives a situation that soup is in a circular pot. Pot wall temperature is controlled by flame. Soup reached steady state. This gives the situation that pot wall is equal to contour C. Temperature on a pot wall is equal to boundary value. Any point inside the soup is equal to interior point, a temperature at the center of a soup. Depends on how hot the pot wall is around. Another application of Cauchy integral formula is in sound and music system. Consider you are listening a radio. Sound wave reflects and spread inside a room. Sound pressure at any listening point depends on speaker output, wall reflection. This is exactly the boundary to interiors relationship described by contour integral formula. Thank you for watching.